Now we will talk about contours and surfaces. I guess you're quite familiar with contours and surfaces, but basically we will have a bit of a review in here. So contours are lines that connect points with the same height. So for example, if we've got a surface that looks like this, so for example, it's like an underwater volcano, for example, basically what we try to do is to cut them in some levels. So we've got the base in here, we've got level 1, and then we've got level 2, level 3, etc. And then each level, we've got the same interval, I'll say I. So how do we do that? So after we've got the surface, and then we can actually make kind of a cross section in here. Imagine that it's a cross section in the middle, and then we could obtain this. And if we cut them through, this is level 1, level 2, level 3, etc. If we have a look at it from up above, then it will basically look like this. As you can see, a more dense, a denser contour lines means it's actually a very, very steep slope. But if it's not that dense, if it's quite sparse, then it means that it's actually a gentle slope. So as you can see in here, if it is drawn on map like this is how it looks like in your cross section. And you can see here again, there's a steep slope over there. Again, if we cut it here, because it has a very, it's not as narrow as this one at least. So it's quite big. And if we cut them, they actually have very, very gentle slopes compared to this one. So for example, that one, that's quite gentle. And here, it's even a lot more gentler. So that's contours. And again, how do we actually do the contours? This is very basic, but I think it's good to review. So basically, you need to start by plotting your sample points on your map. So for example, X and Y, you've got this, and this is going to be, for example, your depth or your height. That's basically what we did already in the practical. And then you will have a set of points. And then the contours are drawn basically based on the proximity of one point to another. So for example, we've got 2.2, 2.1, and 1.9 here, and then you don't have anything in that range again. So we can say that, oh, actually that's 2, that one is 3, and that one is 4. Those are the contour lines of this area at least. But now digitally, we actually make the surface first, and then we will do the contours of the surface. So we need to know how the digital elevation model or DEMs are made. So DEMs, as you know, that's basically a 3D surface that is created by interpolating points observed from the field. And we are going to do that in our practical as well. So the DEM can be modeled using either the grid method. So in the grid method, you compute the elevations on by interpolating points on a set of grids. So you make like a grid out of it. So you've got these points, for example, and then you make a grid first. So you've got, sorry, this grid. Yeah. And then you kind of put them each to the grid. So you've got 24 in here, 20 in here, and then you've got 16 in here, and then the other points outside of those gridded, you interpolate it. And the other method is actually irregular method. So in irregular method, elevations are computed directly around the set of point network. So you don't have to make a grid out of it. So it kind of look like this. So for example, you make a network out of your points, and you can see already from the network that, okay, this area is quite sparse, this area is quite dense. And so you can actually say that, oh, okay, when you're doing irregular method, you actually make it into like a clustered points instead of like in gridded method, you actually make kind of a surface that is normalized in some way. Do you understand what I mean? So we're going to talk about each of the samples, like increased distance weighted, or the EIDW. So we'll talk about that, kriging and spline. Also, we'll talk about natural neighbor in the next segment.